We will now determine the value of cos of a plus b using the given values of cos a equals negative 1 by 2, tan b equals 4 by 3, where a and b both lies in quadrant 3. So first, let me expand this using the sum identity. So according to sum identity, cos of a plus b is expanded as cos a cos b minus of sin a sin b. And here we observe that we only have cos A as of now. We need cos B as well as sin A as well as sin B. So to determine them, I'm going to construct right triangles both for cos A as well as for tan B. So first, let me construct a right triangle for cos A. This is in quadrant 3. So let's say this is quadrant 3. We have the right triangle like this. Let this be angle A. We are given cos A equals negative 1 by 2. Cos A is adjacent side by hypotenuse. So I mark this as adjacent side and hypotenuse is 2. So now we have to determine this another side. We can determine this using the Pythagorean identity. So this side, let's say that this side is AB. So we determine the AB equals, if this is O, this is basically equivalent to OA squared minus of, sorry, it is OB square. This is OB quantity square minus of OA square and under the root. So let's determine this. OB is 2, so therefore this becomes 2 squared minus OA is negative 1. So this is negative 1 squared under the root. And this gives 2 square is 4 minus negative 1 square is 1. So this becomes 4 minus 1. So basically this is root 3. So we can put root 3 here. And this means we can determine the sine A. So therefore we can replace the sine A over here. Or let me write down the sine A. This equals opposite side to A, which is root 3 divided by hypotenuse, which is 2. So we just found the value of sine A equals root 3 over 2. So we now need cos B as well as sin B. We will determine them by constructing the right triangle for the angle B using tan B equals 4 by 3. So let me do that here. We have tan B equals 4 third, and this is also in quadrant 3. So let me construct another right triangle in quadrant 3. So it is like this. So this angle is B. We are given tan B equal to 4 by 3, which is opposite by adjacent. So this is in fact negative 4 because it is down below the x-axis, and this side length is negative 3. So when we find tan B, this will be negative 4 over negative 3, and this is equal to 4 by 3. So basically tan B equals 4 by 3. So we will find this hypotenuse. We can determine using the Pythagorean identity. Let's say this is OP and this is Q. So you have to find OP. This is square root of OQ squared plus QP squared. And this gives OQ is negative 3 when it is squared plus QP is negative 4 when it is squared. So this gives negative 3 square is 9. Sorry about that line. It just came automatically. I have erased it. So negative 3 quantity square is 9 plus negative 4 quantity square is 16. So therefore this becomes square root of 25, and this gives 5. So we can mark 5 in OP. So from this we can determine sine B as well as cos B. So therefore sine of B equals opposite side to B, which is negative 4 over hypotenuse, which is 5. And similarly cos B equals adjacent side to B, that is negative 3 over hypotenuse, which is 5. So now we have all the trigonometric values. We can substitute into the expansion of cos A plus B and determine them. So here we will substitute the values of cos A, cos B and sin A, sin B. So therefore this equals cos A is given as negative 1 by 2, and we found the value of cos B equals negative root 3 by 5. We then have minus sin A is negative 4 by 5 times of sin B is root 3 over 2. So we multiply this first fraction, that is negative 1 times of negative 3 is 3, and 2 times of 5 is 10 in the denominator. We have 2 minus, product of 2 minus is positive, so this becomes 4 times of root 3 over 10. So we have a common denominator, which means we can add the numerators, that is 3 plus 4 root 3 over 10. So therefore the value of cos A plus B equals 3 plus 4 root 3 over 10.